Hey guys, today we are going to talk about algebraic expressions. So an algebraic expression is an expression that may contain numbers, operations, and one or more symbols. The parts of an algebraic expression are called terms. So here we have an expression, an algebraic expression. It has two terms. They're separated by the plus sign. This number right here that does not have an x with it, or a y or any other variable, this is called a constant, okay? The term is called a constant because it has no variable. This number out here in front of the variable is called a coefficient, okay? So this is an algebraic expression. It has two terms here. It has a coefficient here of 5. It's got a constant of 4. Since its biggest power is 1, it is called a linear expression. Basically, later on, we'll find out that this, if we graph this, will make a line. That's why it's called a linear expression. Linear means line. Okay, so here we have two expressions. We have one linear. This one's not linear because it's got a second power to it. We're supposed to find the terms, the coefficients, and the constants of each algebraic expression. So this one here has two terms. It has a term 6x and has 13. Okay, now, coefficients. It has a coefficient of 6, and it has a constant, and that constant is 13. Okay, so let's move over to this one. It has three terms. It has a term 2z squared, it has a term y, and it has a term of 3. It has two coefficients. It only looks like it has one, but it has two. 2 is one of the coefficients, and the y has a coefficient in front. It's a 1. Whenever there's no number there in front of it, that means that it's 1. And it has a constant. The constant is 3. Okay? So, here's what I want you to do. I want you to pause this video. I want you to do the same thing for this. I want you to write down the terms, the coefficients, and the constant of this expression. Then jump back on here and check and see how you did. Okay, this thing has three terms. 15, 3w, and 1/2. Okay, now I can combine the like terms. The like terms would be the 15 and the 1/2. So I can combine those. It has one coefficient. The coefficient's 3. It has two constants. 15 and 1/2. Okay. Hopefully you get that right. Okay, write each expression using exponents. Okay, so this is a nice easy one here. D times D times D times D is D to the 4th power. So there we're using exponents to write that same thing. Over here, this one, 1.5 times h times h times h would be 1.5 h to the 3rd power. You can't really do any more than that. Okay, so here I'd like you to pause the video again. I'd like you to write both of these expressions using exponents and then jump back on and make sure you got it right. Okay, this one right here, there's 5 k's, so you'd write this as 9k to the 5th power, and you're done. Piece of cake. This one over here, you got 6 j's, so this would be j to the 6th power, and you're done. Super easy one. Okay, evaluate k plus 10 when k is 25. So this is a pretty easy little problem. So you're just going to put the 25 in for k right here, and you get 25 plus 10 is 35, and you're done. Okay, on this one, evaluate 4 times n when n is 12. That'd be 4 times 12, which would be 48. Simple stuff. You can do this all day. Okay, here's one for you to do. Pause the video, take a look at this, and then check back and see if you got the right answer. Okay, so if I take 24 plus c, but c is 9, this becomes 33. Okay, evaluate a divided by b when a is 16 and b is 2/3. So this would be 16 divided by 2/3, which you know to rewrite as 16 over 1 times 3 over 2. And now what we can do is we can cancel the 2 and the 16, and we get 8 times 3 is 24 over 1, which is just 24. Okay, evaluate 3x minus 14 when x is 5. So more of the same type of stuff. We can just substitute the 5 in here. So we get 3 times 5 minus 14 would be 15 minus 14, which would equal 1. I want you to show all this work when you do this too. Okay, on this one, now this is a little bit different because there's 3 terms and there's a z squared and a z term. So when I take the 2 and I plug it in for z, I also have to plug it in here. So this is going to be 2 squared plus 2 plus 8.5. So this would be 4 plus 2 plus 8.5. That would be 6 plus 8.5, which would be 14.5. Whoops, that's not what I wanted. Go away. There we go. Okay, on this one, I want you to pause the video and go ahead and do this. 1.5 minus 3y plus y squared when y is 6. Okay, so you should have taken 6, substituted it in here and here. So that'd be 1.5 minus 3 times 6 plus 6 squared. So this would be 1.5 minus 18 plus 36. Now we're going to work from left to right. So 1.5 minus 18 is going to be negative 16.5 plus 36. And that's going to be 19.5. Okay, so there you go. Let's check this problem out. You're saving money to buy a skateboard. You begin with $45 and you save $3 a week. The expression 45 plus 3W gives the amount of money you save after W weeks. How much money will you have after 4 weeks? Well, you'd have 45 plus 3 times 4, which would be 45 plus 12, which would be $57. Now, after 10 weeks, you'd have 45 plus 3 times 10, which would be 45 plus 30, which would be $75. After 20 weeks, you'd have 45 plus, 3 times 20. So you'd have 45 plus 60, which would be $105. Okay, after 20 weeks, do you have enough to buy the skateboard? Well, the skateboard's $125. You have $105, so no, you don't have enough money. need 125, and you could say you are $20 short. Now, in another 4 weeks, you have it. Hopefully the sale's still on at that point. Okay, so here's your assignment. You're going to get to do numbers 1 through 39 odd in class, and I will see you later.